hope you're doing well. My name is Tawfiq Omar Uthman, math teacher. In this video, I will explain Chapter 2, Lesson 4, Vertical Asymptote. Before we start our lesson, we inform you that there is a link in the description below for the exercise of the lesson that you can download it and use it correctly. Please do not forget to subscribe the page and press the button of like and write your comment if you have any questions. Let us start our lesson. A vertical asymptote. If fx tends to positive infinity or negative infinity as x tends to c, then the vertical line x equals c is a vertical asymptote to the graph of the function or to the function. A vertical line that the function is approached to but not cut it or touch it if the function is not a piecewise function. Theorem 2.3. Vertical asymptote. If f and g are two continuous functions, and if fc not equal to 0 and gc equal to 0, whereas gx not equal to 0 near x equal to c, then the line x equal to c is a vertical asymptote to the function hx equal f of x over gx. In other words, we can say that any value of x makes the denominator of a rational function 0 and does not make the numerator 0. Example number 1. Find all vertical asymptote for the function f of x equal 1 over 2 times x plus 1. To find a vertical asymptote, take a new denominator and equal it to 0 and solve this equation. By dividing by 2, then x plus 1 is equal to 0. Take 1 from left to the right, then x is equal minus 1. X equal minus 1 is a vertical asymptote because it makes the denominator 0, but numerator is not 0. As you can see in the graph of the function, x equal minus 1 is a vertical asymptote. As you can see that the function approached to it but not cut it and not touch it. Example number 2. Find all vertical asymptote for the function f of x equal x squared plus 1 x squared minus 1. And now take a denominator x squared minus 1 and equal it to 0. Solve this equation by factoring difference between two squares. X minus 1 and x plus 1 is equal to 0. From x minus 1 is equal 0 or x plus 1 is equal 0. From x minus 1, x equal 1, and from x plus 1, x equal minus 1. As you can see in the graph of the function, x minus 1 is a vertical asymptote and x plus 1 or x equal 1 is a vertical asymptote because make the denominator 0 but numerator is not 0. Therefore, x equal 1 and x equal minus 1 are two vertical asymptotes. Find all vertical asymptote for the function f of x equal 1 over tangent x. Take a denominator tangent x equal to 0. Then solve this equation. Tangent x is equal to 0 when x is n pi for all n in integer numbers. As you can see here, when n is minus 1, then x is equal minus pi. As you can see, x is equal minus 1 is a vertical asymptote. It is a vertical asymptote x equal to 0. When n is 1, then x is equal pi. It is a vertical asymptote. Example number 4. Find all vertical asymptotes for the function fx equal 2 over 3x minus 2. Take a denominator and equal it to 0. Therefore, 3x minus 2 is equal 0. Solve this equation by taking minus 2 from left to right. It becomes positive 2. And then divide it both sides by 3. 3x divided by 3 is x. 2 divided by 3 is 2 over 3. Therefore, x equal 2 over 3 is a vertical asymptote, as you can see at the graph of the function. Example number 5. Find all vertical asymptote for the function f of x equal x minus 1 over x squared minus 4. Let x squared minus 4 is equal 0 and factoring by difference of two squares, x minus 2, x plus 2 is equal to 0, and x equal 2 or x equal minus 2 are two vertical asymptotes. Find all vertical asymptote for the function f of x equal 1 over cosine x. Take a denominator cosine x and equal it to 0. Cosine x is equal to 0 when x is equal pi over 2 plus n pi, when n is an integer number. As you can see in the graph of the function, if we put the n is minus 1, then x is equal minus pi over 2. This is minus pi over 2. It is a vertical asymptote. When n is 0, therefore x is equal pi over 2. It is a vertical asymptote. If n is minus 2, then x is equal 3 pi over 2 minus 3 pi over 2 is a vertical asymptote. When n is 2, then x is equal 3 pi over 2 is a vertical asymptote, respectively, like this. And in all examples, we took there is no common factor between numerator and denominator. And now we will take some example which there is a common factors. Example number 7. Find all vertical asymptote for the function f of x is equal x squared plus 2x minus 4. Before we make the denominator is equal to 0, then we must factoring a numerator and denominator. In this functions, to find the vertical asymptote, follow these steps below. Step number 1, simplify the function by factoring and cancelling common factors. Factoring x squared plus 2x minus 4 minus 8 is x plus 4 x minus 2, and factoring x squared minus 4 is x plus 2 x minus 2. By cancelling, as you can see here, there is x minus 2 and x minus 2 is a common factor between denominator and numerator. Then we cancelling these two common factors and remain fx is equal x plus 4 over x plus 2. And now we make the denominator is equal 0 and solving this equation, then x is equal minus 2 is a vertical asymptote. Example number 8. Find all vertical asymptote for the function f of x is equal x plus 3 x squared minus 9. First of all, by factoring the denominator, it becomes x plus 3 over x minus 3 x plus 3. Cancelling x plus 3 from denominator and numerator, it remains 1 over x minus 3. Make the denominator is equal to 0 and solve this equation. X is equal 3. Then x equal 3 is a vertical asymptote. Example number 9. What are the vertical asymptote for the function f of x is equal x squared minus 2x minus 3 over x squared minus 3x? Here you can see when x is equal to 3, then numerator is 3 square minus 2 times 3 minus 3, and denominator 3 square minus 3 times 3. As you can see, 3 square is 9. 2 times 3 is 6. Minus 6 minus 3 is minus 9. 9 minus 9 is 0. Then it is become 0 over 0. Therefore, x equal 3 is not a vertical asymptote. To find a vertical asymptote in these functions, we can first of all factoring denominator and numerator. By factoring x minus 3 x plus 1 over x minus 3 and cancelling x minus 3 with x minus 3, then fx is equal x plus 1 over x. Make the denominator equal to 0, then x equal to 0 is a vertical asymptote. Example number 10. Which of the following it is a vertical asymptote is x equal minus 3? You can find, as we said before, by making the denominator equal to 0 and solve the equation, find the vertical asymptote. But in the first way, you can replace minus 3 in each function if the result was 0 over 0 is not a vertical, but if it was a number over 0 is a vertical asymptote. Here, let us take the first one, fx equal x plus 3 over x squared plus 3x, and replace x equal minus 3 in this function, then f of minus 3 is minus 3 plus 3 over minus 3 squared plus 3 times minus 3. Minus 3 plus 3 is 0. Minus 3 squared is 9. 3 times minus 3 is minus 9. 9 minus 9 is 0. As you can see here, the result is 0 over 0. Therefore, x equal minus 3 is not a vertical asymptote. And now take B and find the f of minus 3 is equal minus 3 over minus 3 square minus 9. Minus 3 is minus 6. Minus 3 square is 9 minus 9. Minus 6, 9 minus 9 is 0. Therefore, minus 6 over 0, because is not 0 over 0, therefore x is equal minus 3 is a vertical asymptote. That means B is a correct answer. Example number 11. Find all vertical asymptote for the function f of x is equal x minus 1 over x minus 4 when x is not equal 4. It is 5 when x is 4. To find the vertical asymptote in this function, take x minus 4 and equal it to 0. Therefore, x is equal 4 is a vertical asymptote. But the function is defined at x equal to 4. F of x is equal 5. Example number 12. Which of the following is equal to the limit when x approach to 1 from left, x plus 1 over x squared minus 1? 0 minus infinity, positive infinity, minus 1. If the graph is given, as you can see that x equal 1 is a vertical asymptote. When we approach to the 1 from the left is going to the minus infinity, and when we approach to 1 from the right, the function goes to the positive infinity. Because in the left is going to minus infinity, that means B is a correct answer. The first one, you can multiply this negative by this positive and by this positive. That means it is a negative. Or you can, because we are approaching to the 1 from the left, take a number less than 1 or smaller than 1 and replace it in the function in place of x. Let us take 0, then 0 plus 1 over 0 square minus 1 is equal minus 1. Because the result is minus 1, then the answer is minus infinity. Example number 13. Which function of the following has a vertical asymptote at x equal 2 and x equal minus 1, and it is horizontal intercepts is x equal 3? To find this function, you have two ways. First of all, replace x equal to 3 in the numerator of this function. When we replacing x here, therefore it is x3 minus 3 is equal 0. Therefore, this function's intercept, horizontal intercept, is x equal 3. Here, 3 minus 3 is equal 0. Therefore, the x is equal 3 is a intercept, horizontal intercept for this function. But here, 3 minus 2 is 1, 3 plus 1 is 4, 1 times 4 is 4, therefore it is not intercepting is 3, therefore this is not a correct answer. Here 3 plus 3 is 6 is not equal to 0, therefore x equal 3 is not an horizontal intercept for this function 2. That means A or B is a correct answer. To know which one is a correct answer, replace x equal 2 in the denominator. If it make the denominator 0, therefore it is a vertical asymptote. If we replace it here, 2 is plus 2 is 4, not 0. Therefore, A is not correct answer. B is a correct answer. We have another way to find the function. Here you have x equal to 3, x minus 3, and you have here x equal to 2, make it x equal minus 2, and here x is equal minus 1, make it x equal 1. And now write your function like this. Function f of x is equal, because x is equal to 3 is a horizontal intercept, write it x minus 3 in the numerator, x minus 3. And because x equal to 2 and x equal to minus 1 is a vertical asymptote, write it in the denominator like this, x minus 2, x plus 2. And now, as you can see, that the B is a correct answer. The B is correct answer. This is a second way to find or to solve this example. B is a correct answer. Here we came, and please do not forget to subscribe the page and share it with your friends so that everyone will benefit and get each new videos. Write your comment and press like button. Do not forget that there is a link for the exercise of this lesson below the video. Download it and use it correctly. Thank you for watching and goodbye.